All right, our DLO for today is I will learn how to solve compound inequalities. Working out of packet A2 on page 54. So go ahead and look at that page while we work on these. And go ahead and write this title down. If you look at page 54 in your packet, it looks kind of like this. So these are what compound inequalities look like. They're separated sometimes by an or, like you see here, or sometimes they have an and, like you see here. And so we're going to discuss what it means and how that's a little bit different than solving normal inequalities, and what it means for the graphing part of the answer. Because most of the steps to solve it is the same, it's just the graphing part that's a little bit different. So when we're actually working on these, we're only going to work on a few of them, but let's talk about a few notes really quick. So whenever you see or, so let's take some notes really quick. Whenever you see or, all right, this is called it's called an inequality. It looks like this. It's not called something, but it looks like this when you graph it. So or means that when you graph it, the lines go in opposite directions like this. If you see and in between the two inequalities, you're going to see it going like this. And the two lines are actually going to come together, and they will actually create one whole line. So when I have it like this, I'm going to have it like this, and it actually creates one whole line where those are not actually separated from each other. So the arrows point towards each other. So whenever the problem has or in it, it'll look like this. Whenever it has and, they'll go towards each other. So that's kind of to give you an idea of what the two graphs will look like. Now when we solve a compound inequality, it's called compound because there's two of them, and we're solving them together. So we'll do one together. So let's just write number one. We're going to do the first example together. It says 3x plus 2 is greater than or equal to negative 1. Or, I'm going to put a box around that because that's going to be important when we graph our answer. 4 minus x is greater than or equal to 2. Alright, so let's zoom into this a little bit. Alright, now we're just going to solve each of these inequalities by themselves. Alright, like we were doing them as two separate problems, and then we'll look at the answers when we come back together again at the end. So over here in this first one, let's look at this first one. We want to get x by itself. So first it's being multiplied times 3, then it's being added 2. So to do the opposite in the opposite order, we have to subtract 2 from both sides first, using the subtraction property of inequality. When I simplify, I get 3x is greater than or equal to negative 1 minus 2 is negative 3. And then I still have this 3 being multiplied times x, so to get rid of that, I just divide by 3 on both sides, using the division property of inequality. And because I'm not dividing or multiplying by a negative number, the sign is fine and it stays the same, so I get x is greater than or equal to negative 3 divided by 3 is negative 1. So that's my answer for the first part of it. All right, but because it's a compound inequality, it has two parts to it, so we have to make sure that we solve both parts. So now let's go over and look at this part. Well, I see here that my x is now behind my constant, so it's kind of, it confuses students sometimes when they see it like that, but we solve it pretty much the same way. So first, x is being multiplied by a negative 1. Remember how there's an invisible ninja 1 right here? So x is being multiplied by a negative 1, and then 4 is being added to it. You don't see it, but there's a little invisible plus sign right here as well. So 4 is being added to it, and that negative 1 is being multiplied times it. So, to get rid of the 4, because we always want to move our constants over to one side, to get rid of the 4, we subtract 4 from the left and subtract 4 from the right, using the subtraction property of inequality. So these are additive inverses. Those are going to add to 0. So on the left I have negative x, and on the right I have 2 minus 4, which is negative 2. And then last but not least, again, remember that ninja 1 we were talking about. So because I have negative 1 being multiplied times x, I'm going to divide by negative 1. That's called the division property of inequality. And here, if I look over here, these are multiplicative inverses, so those are going to multiply to 1. So on the left, I'm left with x. Now here I divided by a negative number, so I have to be careful about that sign. I have to switch my sign So I say that x is less than or equal to negative 2 divided by negative 1. Well, a negative divided by negative is a positive, so that's positive 2, because 2 divided by 1 is 2. So my solution set is x is greater than or equal to negative 1, and x is less than or equal to 2. Alright. So when we graph this on a number line, we graph it like this, and we have to put negative 1 and 2 on there somewhere. So we have 0, 1, 2. And we have negative 1, negative 2. So here, I have at negative 1, I have greater than or equal to. So because it's also equal to at negative 1, I'm going to put a closed circle. And over here I have x is less than or equal to 2. So over here at 2, I'm going to put a closed circle. Alright, now you might remember up at the top that we put that our graphs look like this, but I actually want to amend that a little bit. Because these and these ors don't necessarily correspond to these ors. So I'm actually going to do me a favor, put a little bubble around this, and then just put not yet. We'll come back to that later. I don't want to confuse you, so we'll leave it there, but we're just going to put not yet. Alright, good. So this is important, but it's not important yet. So hold on to that knowledge up there. We'll come back to that later when we do want to talk about it. For right now, let's talk about what it means to have an or here. So here's I guess some notes we can add to it. So over here to the right hand side, let's write this down. If you see greater than, alright, greater kind of sounds like great or. Alright, so whenever you see greater than, like these symbols here, we have greater than negative 1, greater than 2. Alright, so greater is like greater. Alright, and then if you see less than, it kind of looks like less than. Alright? So whenever you see less than symbols, like in the next problem we're going to do, you can think of it like less than, because the and comes from that. So when we look over here at our problem, let's try and do this one more time. So we have x is greater than negative 1, so it's all the numbers bigger than negative 1, and x is less than 2, so it's all the numbers less than 2. So that has to be all the numbers between these, because if you think about where you're shading, these are all the numbers greater than negative 1, like 0, 1, and 2, and these are also all the numbers that are less than 2, also like 0, 1, and 2, those are less than 2. Now the reason we can't go outside of this is because as soon as we go over to negative 2, alright, that no longer works for this one, because negative 2 is not greater than negative 1. And as soon as we go over here to like positive 3, that no longer works for this one, because positive 3 is not less than 2. So our solution set, when we have these two compound inequalities together, would be all the values between negative 1 and positive 2. Alright, so that's our first example for today. We're only going to do one more. So let's look at number... let's look at number 4. Alright, so it says 2x minus 3 is greater than 3, and x plus 4 is less than or equal to 1. So again, I see less than, so I see less than, and let's talk about this. So let's solve this one first. I want to bring all my constants to one side, so I see this negative 3 that I want to get over here. So I'm going to add 3 to both sides using the addition property of inequality. These are additive inverses. So I'm left with 2x is greater than 3 plus 3, which is 6. And then I want to get rid of that 2, that coefficient of 2, so I'm going to divide by 2 on both sides using the division property of inequality. And these are multiplicative inverses, so those are going to multiply to 1. So I'm left with x is greater than 3. Alright, so that's the first one. Let's look at the second one. The second one actually only requires one step because I have one constant here that I want to move over to the other side. So because it's being added to x, I'm going to subtract it from both sides. So subtracting 4 on both sides gives me x is less than or equal to 1 minus 4, which is negative 3. So I have x is greater than 3 and x is less than or equal to negative 3. So when I graph these together on the same graph, alright, I have to graph the points 0 to 3, 1, 2, 3, and 0 to negative 3, negative 1, negative 2, negative 3. Alright, good. So when I graph these, let's look at this one. It says x is greater than 3. So it's going to be an open circle because it's not greater than or equal to. An open circle at 3. And it's all the numbers greater than 3, or in other words, all the numbers bigger than 3. So like 4, 5, 6, 7, 8. So it's all the numbers this way. And then this one, x is less than or equal to negative 3. So over here at negative 3, I have less than or equal to, which means it's a closed circle. And less than negative 3 would be numbers like negative 4, negative 5, negative 6. So it's all the numbers this way. Alright, so those two go in opposite directions. So the first example we did, they went together. This example that we're doing, they go in opposite directions. Because we could tell from these two compound inequalities that that's what happened. Good. So, I want to write these two. We're going to come back to number 1 and we're going to do these two together. But I want to write their answers as a solution set. So we're going to write it in set notation. Alright, so when we write it in set notation, we write it like this. So back for number 1, so make sure we're back at number 1 again. Back at number 1, remember we write x such that, now that we have two answers, here's how we write it. Because they go together, alright, we can write it like this. We start at negative 1 because that's the smallest number. You always start at the smallest number. And you say that negative 1 is less than x, and x is less than, or I guess we could put less than or equal to, and x is less than 2. So again, negative 1 is less than or equal to x, which is less than or equal to 2. So that includes all the values in between 1 and 2. For this one down here, we start the same way. We say that x such that. Now over here, the smallest number is actually way over here at like negative infinity. Alright, because our arrow is pointing this way. And so they don't go together this time, so because they go opposite directions, we're actually going to have two pieces to this. So we're going to say that either x is less than or equal to negative 3, like we see up here. That's one of the pieces. You can say, or the other piece, which is this one, x is greater than 3. And that's how we write it in set notation. Alright, good. So these are the two types of different inequalities that you're going to see. So make sure that you have both of those written down on your notes. And then when you're done with that, we'll be good for today. Thank you very much.